Welcome. Today, we're exploring a powerful approach to contamination control by integrating two key methods, CIP and CIP. Together, they offer a smarter, more effective way to keep processes clean and safe. Let's dive into how this integration can enhance control and improve outcomes across the board. Let's start with the basics of contamination control in pharmaceutical manufacturing. It's a top priority, both for meeting regulations and ensuring quality. Two key technologies make it happen. First, cleaning in place, or CIP, which removes everything from product residues to biofilms. Then, sterilization in place, or CIP, which kills microorganisms, spores, fungi, and yeasts. The core idea is simple. CIP cleans, CIP sterilizes, and together they keep manufacturing running in a controlled, safe state. When we talk about key regulatory references, we're looking at some major players. The European Commission and the U.S. Food and Drug Administration set important standards. Then there's the World Health Organization, the International Council for Harmonization, and the International Society for Pharmaceutical Engineering, all guiding how we do things. The core expectation. Cleaning and sterilization processes must be scientifically designed, validated, monitored, and maintained throughout the entire equipment lifecycle. It's about consistency and safety every step of the way. Our goal here is clear: to deliver equipment that's both clean and sterile before it ever touches the product. We do this through two key processes, CIP and CIP. CIP stands for Clean in Place, focusing on removing residues and contaminants using water, detergents, and chemicals. CIP, or Sterilize in Place, targets microorganisms and spores, typically using saturated steam. CIP ensures equipment cleanliness, while CIP guarantees sterility. Each process has its own validation focus, CIP on residue removal and CIP on microbial destruction. Together, they keep our operations safe and effective. Let's talk about why integration is absolutely critical. The science is clear: sterilization alone can't make up for poor cleaning. If protein residue is left behind after cleaning, it can actually shield microorganisms from steam during sterilization. It also creates spots where biofilms can form, making sterilization less effective. The key GMP principle here is simple: you can't sterilize dirt. Effective cleaning has to come first, or sterilization won't do its job. Let's walk through an integrated contamination control strategy, a step-by-step flow that keeps manufacturing safe and clean. It starts with the manufacturing process itself, where product residues can build up. Then comes the cleaning in place cycle, designed to remove those residues. After cleaning, we verify that the residues are truly gone. Next, the sterilization in place cycle kicks in, ensuring sterility. Finally, aseptic manufacturing takes place, maintaining that sterile environment. Together, these steps create a comprehensive barrier against contamination throughout the entire manufacturing lifecycle. When designing CIP-CIP systems, we need to keep several key equipment requirements in mind. The design must be hygienic, with no dead legs where fluid can stagnate. Systems should be self-draining, ensuring every surface is cleaned thoroughly. Complete spray coverage is essential, along with effective steam penetration for sterilization. Sanitary valves and fittings help maintain cleanliness throughout. From a regulatory standpoint, equipment has to support both cleaning and sterilization effectively. For example, bioreactors often include integrated spray devices and steam networks to meet these needs. Let's talk about how we validate integrated CIP-CIP systems. CIP, or Clean in Place, validation shows us that product and detergent residues are properly removed, and that cleanliness meets required standards. On the other hand, CIP, or Steam in Place, validation proves microbial destruction, sterility assurance, and temperature uniformity. The ultimate goal here is to demonstrate that cleaning and sterilization don't just work separately. They work together seamlessly to ensure safety and quality. Here, where we see the outcome of our validation efforts. The equipment is now approved for sterile manufacturing, meeting all critical parameters. Temperature mapping, biological indicators, and sterility assurance all passed with flying colors. Our CIP validation confirmed no product or detergent residue, and total organic carbon levels stayed within limits. This integrated validation study focused on a 5,000-liter vaccine formulation vessel, a key piece of equipment. Finally, our CIP validation results also met the required standards, ensuring cleanliness and safety throughout the process. Our objective here is clear: to minimize contamination risks before they happen. We do this by applying targeted control strategies for each potential risk. For example, validating cleaning processes tackles residue carryover, while routine checks prevent biofilm formation. Steam penetration is confirmed through sterilization validation, and sterile hold procedures guard against recontamination. Engineering controls address equipment design issues. All these efforts are grounded in a risk-based approach, guided by quality risk management principles from the International Council for Harmonization. Let's talk about monitoring and continuous verification, two crucial parts of keeping processes reliable and safe. For cleaning in place, or CIP, we track things like flow rate, temperature, detergent concentration, conductivity, and total organic carbon. For sterilization in place, or SIP, temperature, pressure, hold time, and steam quality are key. The industry is moving toward continuous process verification, which means we're checking these parameters all the time, not just at set intervals. This shift helps catch issues early and keeps everything running smoothly. Let's talk about digitalization and smart CIP-SIP systems, where emerging technologies are changing the game. We're seeing smart sensors, SCADA systems, industrial IoT, artificial intelligence, electronic batch records, and digital twins all working together. For example, a real-time dashboard can monitor rinse conductivity, temperature profiles, and equipment status all at once. The result: we get enhanced visibility into contamination control, making processes safer and more efficient than ever before. Let's look at the outcome of our integrated cleaning and sterilization approach in a biopharmaceutical facility. Before, they faced recurring microbial excursions and cleaning deviations, real risks to product safety. After making targeted changes, like optimizing spray coverage and adjusting piping, those excursions dropped from 8 a year to 0. Cleaning deviations nearly disappeared, and sterility failures went from 2 to none. This case shows how focused improvements in cleaning and sterilization can dramatically boost contamination control and regulatory compliance. When we integrate CIP and SIP systems, the benefits are clear and compelling. We get enhanced contamination control and improved sterility assurance, which means the risk of cross-contamination drops significantly. Operations become more efficient, regulatory compliance strengthens, and product quality improves. Ultimately, this leads to better patient safety. Plus, it supports the move toward Pharma 4, embracing smarter, more connected manufacturing. Regulators expect manufacturers to prove these systems work seamlessly together to keep everything validated and under control. Looking ahead, integrated CIP-SIP systems are set to become smarter and more autonomous. We're talking about AI-driven cleaning optimization, where systems learn and adapt in real time. Predictive sterility assurance will help us catch issues before they arise. Autonomous cycles will reduce human intervention, while continuous verification and real-time monitoring keep quality front and center. Digital twins will let us simulate and perfect processes virtually. All this ties into Pharma 4, moving us towards self-optimizing systems that ensure contamination control around the clock. To wrap up, integrating cleaning in place with sterilization in place creates a complete approach to contamination control. It's about removing residues thoroughly and killing microbes reliably. When manufacturers use risk-based validation, smart monitoring, digital tools, and ongoing checks, they boost product quality and sterility, while staying efficient and compliant. As we move into Pharma 4, these integrated systems will be key to smart, data-driven contamination control that protects patients and supports sustainable manufacturing. Thanks for joining me today. If you want to explore this topic further or have any questions, please don't hesitate to reach out. I appreciate your time and attention, and I look forward to continuing the conversation. Thank you. This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.